Welcome to Cambridge IGCSE Physics, Lesson 1.2. 1. What is physics? Physical quantities. This is our first lesson in the core content, where we explore the fundamental nature of physics as a science and understand how we measure the physical world around us. Let's examine our learning objectives for today. By the end of this lesson, you will be able to, first, understand what physics studies as a science. This means recognizing physics as the study of matter, energy, and their interactions. Second, identify common physical quantities in everyday situations. These are measurable properties like length, mass, and time that we encounter daily. Third, recognize that all measurements require appropriate units, understanding that numbers alone are meaningless without proper units. These objectives align with Assessment Objective 1, focusing on scientific knowledge, vocabulary, and concepts. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, physics, which means the study of matter, energy, and their interactions. It explains how the universe works at all scales. Second, physical quantity, which means any measurable property of objects or phenomena. Examples include length, mass, time, and temperature. Third, measurement, which means the process of finding a numerical value with appropriate units. Without units, numbers have no scientific meaning. Understanding these terms precisely is crucial. Remember to use SI units, which stands for International System of Units, the global standard for scientific measurements. Let's explore what physics actually is. Physics is a science that studies natural phenomena through careful observation and controlled experimentation. The fundamental principle is that physics seeks to understand how the universe works by examining patterns and relationships. Physics studies four main areas. First, matter, everything that has mass and occupies volume, from atoms to galaxies. Second, energy, the ability to cause change or do work, existing in many forms like kinetic, potential, and thermal. Third, forces, interactions between objects that can cause acceleration or deformation. Fourth, motion, change in position over time, described mathematically. The scientific method guides physics. We observe phenomena, form hypotheses, design experiments, and analyze results. The diagram illustrates how these four areas interconnect around physics as the central science. Now we examine physical quantities in detail. A physical quantity is any property that can be measured and expressed numerically with appropriate units. The definition emphasizes that measurement requires both a number and a unit. Examples in daily life include length, which is the distance between 2 points, measured in meters; mass, which is the amount of matter in an object, measured in kilograms; time, which is the duration of events or processes, measured in seconds; temperature, which measures thermal energy, measured in Kelvin or Celsius. The key point is that all quantities need both numbers and units. Saying 5 is meaningless. We need 5 meters, or 5 kilograms. The table shows fundamental quantities with their SI units, which are the international standard units used worldwide in science. Let's work through our first example. The problem states, a student walks 500 meters in 100 seconds. Identify all physical quantities and their units. We are given distance equals 500 meters and time equals 100 seconds. We need to find all physical quantities with their correct units. Step 1. Identify the quantities. Distance and time are directly given in the problem. Step 2. Check the units. Meters, symbol M, and seconds, symbol S, are both SI units, so they're correct. Step 3. Calculate additional quantities. We can find speed using the equation speed equals distance divided by time. Step 4. State the answer. Distance equals 500 meters, time equals 100 seconds, and speed equals 5 meters per second. Note that ms means meters per second, showing distance per unit time. Example 2 applies measurement analysis to real data. The problem is, analyze measurement data for object mass to find the most reliable value. The data shows 5 readings: 2.1 kilograms, 2.0 kilograms, 2.2 kilograms, 2.1 kilograms, and 2.0 kilograms. Now we analyze systematically. First, calculate the mean value. Adding all readings gives 10.4 kilograms. Divided by 5 readings equals 2.08 kilograms. Second, identify the measurement range. The highest reading is 2.2 kilograms. The lowest is 2.0 kilograms, giving a range of 0.2 kilograms. Third, assess precision. The small range indicates good precision. Fourth, state the final result. The mean is 2.08 kilograms, rounded to 2.1 kilograms to match the precision of our measurements. The graph shows the individual readings as blue points and the mean as a red dashed line. Mathematical skills are crucial in physics calculations. Let's examine 3 essential skills. First, unit consistency. Always check that all quantities use the same unit system. SI units are preferred internationally. Convert when necessary. 1 kilometre equals 1,000 metres, so always convert to base SI units before calculating. This prevents errors and ensures accuracy. Second, derived units. Some quantities combine basic units. Speed uses meters per second, written as ms, showing distance per unit time. Density uses kilograms per cubic meter, written as kg/m3, showing mass per unit volume. Understanding how units combine helps check if calculations are correct. Third, scientific notation. Large numbers like the speed of light, 3 times 10 to the power 8 equals 300 million. Small numbers like electron charge, 1.6 times 10 to the power minus 19 equals a decimal, with 18 zeros before the digits. Scientific notation makes very large and very small numbers manageable. Now practice what you've learned with these 3 questions. Question 1 is basic level. It asks, list 3 physical quantities you can measure in this classroom. Think about measurable properties around you. Length, mass, time, temperature are all possibilities. Question 2 is intermediate. It states, a car travels 120 kilometers in 2 hours. Calculate the speed in meters per second. This requires unit conversion and calculation skills we've discussed. Question 3 is advanced. The question is, explain why 25 alone is not a complete measurement. This tests your understanding of why units are essential in physics. For all questions, remember to show you're working clearly, include units in every step, and check your answers make physical sense. Write your answers now before looking at the solutions. Physics principles power our modern world. Let's see how today's concepts apply in practice. In technology, GPS systems, which stands for Global Positioning System, measure time intervals with nanosecond precision and calculate distances to determine your exact location anywhere on Earth. In medicine, MRI scanners, meaning magnetic resonance imaging, measure magnetic field strength and radio wave frequencies to create detailed images of internal body structures without surgery. In engineering, bridge design requires precise calculations of forces, stresses, and material properties to ensure structures can safely support loads. These applications show why understanding physical quantities and measurements matters. Career-wise, physics knowledge leads to many professions. Engineering designs solutions using physics principles. Medicine uses physics for diagnosis and treatment. Research advances our understanding of the universe. Technology sector needs physics for innovation, and renewable energy requires physics to develop sustainable solutions. Let's review the solutions. For question 1, possible answers include length, such as desk width, measured in meters; mass, such as book mass measured in kilograms; time, such as lesson duration measured in seconds; temperature, measured in Celsius or Kelvin, is also acceptable. For question 2, we calculate step by step. Speed equals 120 kilometers divided by 2 hours, giving 60 kilometers per hour, converting to meters per second. 60 kilometers equals 60,000 meters. 1 hour equals 3,600 seconds. So 60,000 divided by 3,600 equals 16.7 meters per second. For question 3, the number 25 alone is meaningless because it lacks units. It could represent 25 meters of length, 25 kilograms of mass, or 25 seconds of time. Without units, we cannot interpret the measurement. Now, exam success tips. First, always show you're working clearly. Even if the final answer is wrong, you earn marks for correct method. Second, Include units in every step of calculation. Third, check if your answer is reasonable. If you calculate a human mass as 5,000 kilograms, something is wrong. Fourth, read questions carefully and identify command words. State means give information. Calculate means find a numerical answer. Explain means give reasons. Let's summarize today's lesson. The key points to remember are: first, physics is the science that studies matter, energy, forces, and motion through systematic observation and experimentation. It seeks to understand how the universe works at all scales, from subatomic particles to galaxies. Second, physical quantities are measurable properties that require both numbers and units to have meaning. Examples include length in meters, mass in kilograms, and time in seconds. Without units, numerical values are scientifically meaningless. Third, SI units provide the international standard for scientific measurements, ensuring consistency and communication across all countries and cultures. These three concepts form the foundation for understanding all physics. For further study, review your definitions regularly and practice identifying physical quantities in everyday situations. Master unit conversions between different scales. The next lesson covers measuring physical quantities, which builds on today's work by exploring how we actually make precise measurements using scientific instruments. Ensure you understand today's concepts before moving forward, as physics builds systematically with each lesson connecting to the next.